the nature and properties of X-rays. We'll explore what X-rays are, how they behave, their unique properties, and their applications in real life. So let's get started. Slide 2, Introduction to X-rays. X-rays are a type of invisible electromagnetic radiation. They were discovered in 1895 by Wilhelm Conrad Röntgen, who noticed that these mysterious rays could pass through solid objects and create images on photographic plates. Since then, X-rays have become an essential tool in medicine, industry, and science, from detecting bone fractures to studying atomic structures. Nature of X-rays. Let's understand the nature of X-rays. First, X-rays are invisible and belong to the electromagnetic spectrum, just like visible light, radio waves, and gamma rays, but with much shorter wavelengths. They travel in a straight line at the speed of light, which is about 3 × 10 to the power of 10 centimeters per second in vacuum. And importantly, X-rays are neutral, meaning they are not affected by electric or magnetic fields. Slide 4, Properties of X-rays, Part 1. Now let's discuss some key properties of X-rays. They are highly penetrating, which means they can pass through materials like skin and muscle, but are absorbed by denser substances like bones or metals. They can ionize solids, liquids, and gases, producing charged particles. X-rays also affect photographic films. This is how traditional X-ray imaging works, and they can cause fluorescence in certain crystals, making them glow when exposed to X-rays. Slide 5. Properties of X-rays, Part 2. X-rays also produce biological and chemical changes in matter. For example, they can damage living tissues, which is why their exposure is carefully controlled in medicine. They can cause secondary radiations when passing through a medium. X-rays obey the inverse square law, meaning their intensity decreases rapidly with distance. And finally, they have a broad spectrum of energy, ranging from a few kiloelectron volts to several megaelectron volts, covering a large portion of the electromagnetic spectrum. Slide 6. Diagram, X-ray tube. To understand how X-rays are produced, let's look at the X-ray tube. Inside the tube, electrons are emitted from a heated cathode and accelerated towards a metal anode using high voltage. When these high-speed electrons strike the anode target, their kinetic energy is converted into X-rays. The X-rays then emerge through a small window and are used for imaging or experiments. This setup demonstrates the basic principle behind all X-ray machines. Slide 7. Applications of X-rays. X-rays have a wide range of applications. In medicine, they're used for radiography and CT scans to visualize bones and internal organs. In airports, X-rays help scan luggage and detect hidden items. Industries use X-rays for non-destructive testing of materials and welds. And in science, X-ray crystallography is used to determine the structure of complex molecules like DNA and proteins. Slide 8, Summary. To summarize, X-rays are electromagnetic waves with short wavelengths and high energy. They can penetrate various materials, cause ionization, and are useful for both imaging and analysis. However, because of their biological effects, controlled and limited exposure is essential. So, that was all about the nature and properties of X-rays.